Hello, and welcome to today's New Equipment Digest and American Machinist webinar titled Getting Started with Cobot Welding, sponsored by Universal Robots. I'm Robert Brooks. I'm the editor and content director of American Machinist. Before we begin, let me explain how you can participate in today's presentation. First, if at any time you're having audio difficulties or slides are not advancing, simply hit your F5 key to refresh the webcast console. If you're running pop-up blocking software, you will need to disable it to view the webinar. If you have any technical difficulties during today's session, please press the !help button in the upper right corner to receive assistance in solving common issues. This webinar technology allows you to resize the presentation by clicking the maximize icon in the upper right corner to enlarge the window. We welcome your questions during today's event. To submit your questions, simply type a question into the Ask a Question window on the left side of the screen, and then hit the Submit button. We'll be answering as many questions as possible during the Q&A session that will follow the main presentation. But please feel free to send in your questions at any time, and we'll add them to the queue. Be sure to check out the resources area on your console for information provided by Universal Robotics and Hirebotics. Also, please be aware that today's session is being recorded, and it will be available on the New Equipment Digest and American Machinist websites within the next day for you to review. You will be notified by email when the archive is available. When the webinar ends, please take a moment to complete the feedback form that will appear on your screen. Now I want to welcome our speakers. Will Healy III is Global Industry Segment Manager for Welding with Universal Robotics Teradyne. A Purdue University mechanical engineer who loves to share his passion for automation, Will is a leader at Universal Robotics and with the Advanced Manufacturing Industry Partnership in Cincinnati. He speaks from 16 years of personal experience about people-centric technology investments, managing culture change in organizations, bridging the manufacturing skills gap, and creating through automation. Follow Will on YouTube, Twitter X, and LinkedIn with the handle Will Automate. Rob Goldiez is co-founder and CEO of Hirebotics. As CEO and co-founder of Hirebotics, Rob leads his teams as they design and develop tools to improve the productivity, usability, and affordability of collaborative robot systems. Hirebotics entered the welding automation space in 2019 as a key collaborator in the development of an early Cobot welding system. In 2020, Hirebotics launched Beacon, a power robot software platform with support for applications, remote monitoring, and 24/7 global support functionality. For more information about our speakers, check out the Speaker Details tab on your console. With that, welcome to both of you. Will, the floor is yours.
Awesome. Thanks, Robert. Really appreciate it. So I'm really glad everybody is here today. Thank you for joining us. And thanks to Rob for co-presenting with me. And we're really excited to share with you today about automation and about collaborative welding and the value that can come from collaborative welding. So the first place that I want to start is why collaborative welding? Why is this something that we're talking about and is really growing really quickly in the industry and has so much momentum? And so when we look at collaborative welding, it's because there are some major challenges that we're facing inside the metalworking space and specifically inside of welding itself. Generally speaking, we're looking at workforce shortages everywhere. The census reports 10,000 boomers a day are retiring. 10,000 boomers a day are retiring. And so that is having a major impact on our workforces. And you're probably seeing that in your own companies or in your own customers. And then we're looking at things like 360,000 new welders are needed, according to the AWS on their welding workforce website. 360,000 new welders will be needed by 27, and about 90,000 new welding jobs will be posted every year, including 23, from now until 27. And so 90,000 new welders are needed, and our schools are not graduating that. And so that's a major labor challenge for us in the United States, and welding's a major labor challenge around the world, because this isn't just someone that's running a fryer at Wendy's yesterday and they don't become a welder the next day. This is a skilled task and a skilled job. And then when we look at the Bureau of Labor Statistics data, the June data was reported here on August 1st. And so the first half of the year is in, and there are 1.1 million unfilled manufacturing, transportation, and warehouse jobs. And the interesting thing is that's 1.1 million in our space, but there's 1.8 million unfilled jobs in the retail, accommodation, and food service space. And there's another 1.8 million unfilled jobs in hospitals and healthcare and social assistance. And there's 9.6 million unfilled jobs in the United States. And so there are workforce shortages everywhere. And so we've really got to think about how are we making our places an interesting place to work. And then when we look at our businesses, we're having negative impacts on our business by not having our talent pipeline filled. I have many manufacturers tell me that they've had to turn away business because the job required 10 welders and they only have 6 full-time welders, and they have a hard time keeping those 6 positions filled. Or they just don't have enough capacity or throughput, or the quality expectations are too high. And so there's a lot of different things. When we have idle machines, or we have idle bays, or we have idle equipment that doesn't have an operator at it, that doesn't have a welder at it, that doesn't have someone working that machine, that is having a negative impact on our business. It's making our lead times longer. It's raising our overtime costs on per part costs because of overtime and weekend work. And so we've got to think about, how do we implement and invest in our talent pipeline so that we can run our business and we can grow. And so, the other thing that's really a challenge in this space is welding isn't the easiest job. This is a repetitive task, even in smaller volumes. If you've got to weld a 6-inch straight line 200 times, that's a pretty boring task. It's also, you got the hood on and all the gear. This is a dark and dirty task. Maybe the welder themselves doesn't care about how dirty they are, but maybe their spouse and their family care about them coming home dirty, and all that extra time at the end of a shift that they have to take to clean up and clean up from the work. And then also it's dangerous work. There's hot sparks flying through the air. Things catch on fire. We hope not, but it happens. And there's lots of other things that are going on in there, like lifting big heavy metal parts and positioning heavy metal parts, and bending over a table for multiple hours a day, causing repetitive stress injuries. And so this is a task that's pretty physical and can be challenging for a lot of welders. And so what can we do to beat this kind of chaos in production welding, from not having enough people and having to turn away business, and from the job being pretty physical and challenging, and then just having shortages in total? It really comes down to, how can you amplify your welders? And you can do it with Cobot Welding. And Cobot Welding has this really interesting opportunity as a tool for welders to really boost their productivity and to help them be more productive, and to help focus them on work that they want to do. Welders want to solve problems. They want to do creative things. And so those 200 straight line 6-inch welds, those are things that a cobot does very well. And that allows your welder to focus on prepping the next part, or doing a quality inspection on the part, or doing a more complex weld that maybe you want the welder doing, while the cobot does some of the other welds that are more boring. And so this can amplify the welders in their productivity. It can boost the consistency of how many parts you make per shift. There's a lot of opportunities for how we can do that with collaborative welding. And so what is in a solution? We're going to show you, and Rob's going to demonstrate live for you in a couple minutes, what the Hirebotics collaborative welding system looks like and how it works. But there are basically four main components inside a system to make it work. And it's the cobots, the universal robot, you see that there. And then you have the work area where it's going to work and the tooling and fixtures that you're required to make that happen. And then the dress out kit with the torch and the pipe and the wire feeder and the power source and all those kinds of pieces to make the robot into a welder. And then the software to make it work. And that's really the magic here with the Hirebotics solution. And so with the software for teaching the path and then for controlling the power source as well, like the ESOB power source you're gonna see today. And so when we look at what collaborative welding is doing, it's this valuable tool that's amplifying your welders and it's expanding their productivity. We see time and time again, it raises the arc time per shift, 2x, 4x, 10x. We have some case studies we're going to talk about in a minute. We drive production consistency, improving the product quality, reducing the grinding and the rework queues. No one shows up to work thinking, I want to grind parts today. And then, transferring those dull repetitive tasks to the cobot and making it more predictable for you. How many parts is that weld shop? How much arc time am I going to get today? How many arcs am I going to strike today? That's really important for being able to predict the output of your production and to make you profitable. And then it also, and this is really valuable, increases welder engagement and retention. And we see that a lot in the stories. It reduces the physical demands, reduces the exposure to hazards like smoke coming out of and fumes coming out of the welding process. And it focuses the welder to the creative and challenging tasks and keeps them more engaged. And that's going to help you retain more welders. And so we've always embraced new tools in work. When we look at anybody who's assembled an IKEA system, right? If you're using a little wrench, that's really torturous, right? When you have to put together 200 screws by hand with a little wrench, right? You get calluses on your fingers and you're just really tired and it's draining. And so we have screwdrivers and we have torque guns and we have Ethernet controllable torque guns, and we have invested in technology over time in our processes to make it easier for the worker, to make the worker more efficient, to help the quality of the installation and that we get the right torque rating on the assembly. We have always embraced new tools in work, and this is a new tool for you to really amplify your welders and help them be more productive and to really drive engagement with them. So all of this is really nice in theory. How does it work in the real world? And Rob and I prepared 10 stories to share this with you. And I'm going to let Rob talk about each of these stories briefly as we go through them. So Rob, you want to talk about D'Angelo?
Yep. Thanks, Will. I appreciate it. And feel free to jump in if you think I've missed anything on here. But, D'Angelo Marine, company in South Florida that makes exhaust systems for the marine industry, the yacht industry, been TIG welding these parts for many, many, many years. And, was fascinated with this cobot welding, revolution that's happening. And, what's interesting about D'Angelo is a few things, right? One is they moved from a TIG welding process to a MIG welding process and got about 10x improvement in productivity by moving from a TIG welding process to a MIG welding process. And the other piece is that they don't have any robots on the floor. And so as they were doing the evaluation process to look at cobot welding, they went to all the experts out there with all different types of systems and things like that. And those folks couldn't weld their parts like they could. And so what was key to them being successful with the cobot welder that they have is putting something in the hands of their welders that their welders could use. So they know how to weld their parts. They understand TIG welding, MIG welding, and they have a very easy to use system that's highly productive and embraced by their team.
Cool.
We'll hop forward to the next one.
Yep.
Oh, did I double forward?
I got you.
All right.
There you go.
Siouxland Fab, they've been a longtime user of our technology and have 3 systems on their floor. They started with one. They were extremely productive with it. And as their business grew, due to being able to solve some of these labor pain points around welding, they saw an opportunity to grow their business with more systems. And so they're a customer that started with one, which is very common. And as they became productive, they added more to their fleet. We'll go forward to the next one, Will.
Yep.
Thank you. So IMS in South Carolina, they're a supplier into the heavy equipment industry and have tons of experience with traditional robot programming, traditional robots. These are the big robots that are in cages because they're not safe to be around. And once they got their hand on a couple of the cobots and even benchmarked them against other robots, that companies that have gotten into the cobot space, they found the software and ease of use of the universal robots and Hirebotics system to be far easier and far superior. And so they have a couple of systems that they empower their welders with. They're connected. They can take the tablet, which you'll see in a second, and walk between different robots that they have from us to teach different parts, support their operators wherever they are in their facility.
What I love about this story is they've used traditional robots and they use this, and they love how approachable the programming is of this collaborative welding solution versus the traditional welding. I mean, it says in the quote there, multiple hours to get a part running versus 10 to 20 minutes. And that's just huge. That's really incredible.
Yeah. And for them too, right? Floor space is always a constraint in any manufacturing facility. And their parts are, tabletop size, maybe a little bit bigger, but if you're trying to do those parts on traditional robots, you've got a lot of floor space, a lot of caging and things like that to deal with. And you can fit a lot more collaborative systems into the same floor space that you can fit a traditional system.
Oh, great point. I didn't even think of that. Okay, Athena Manufacturing out of Texas.
Yep, Athena Manufacturing down in Austin, Texas. They supply into a lot of different industries, but the semiconductor industry is one of their big ones. And semiconductor industry, as we all know with the CHIPS Act and stuff like that, with the reshoring, has driven a ton of capital investment into the semiconductor industry in establishing these fab sites in the US. And so Athena's business has been growing. They have traditional robots doing traditional welding with traditional robots and sanding and other applications. They even have cobots doing other applications. But when it comes to welding and the effort to get welding productive, right, having a partner that has software that makes it easy to use was key. So Athena, another customer, they started with one. They started to bid on more jobs and more opportunities beyond what their single cobot could do. Now they have 4 systems. They have external positioners that they've helped design and incorporate into the system to do very large parts with 2 robots and a lot of smaller parts as well.
This is a great example of they were turning away business because they didn't have enough welders and they weren't able to do it. And what I really thought was interesting is because of how easy the solution is you're going to show, they were able to take people who didn't even know welding, that didn't know how to use a robot, and teach them as operators to operate the system and produce parts. And so they were able to actually make more parts and accept more business because of this investment. And I thought that was really interesting. And not that it was eliminating welders' jobs, but that, we can't find welders. And so it was an opportunity to have the welder kind of oversee the production versus just arcing all day.
That's right. That's right. Next company, Swift Metal. This is a customer down in Australia. And so, Hirebotics is based in the US, but we sell all over North America and internationally as well. And so this is a customer internationally in Australia. And what's interesting is, we all tend to be very locally focused. We think about the US, we think about, if you're in Indiana, what's going on in my local market, but these labor shortage problems are everywhere. And so as companies globally evaluate how do they solve their labor challenges, Cobot Welding continues to pop up. And, our strong belief is that ease of use will drive the day, because a lot of these customers are first-time automation users, and first-time automation users are trying to de-risk what their investment is. And the best way to do that is through an easy-to-use system. And you're going to see in a few minutes, as Will mentioned, I'm going to go through, I'm going to share a screen, and we're going to teach some parts so you can see how easy it is. Everybody throws around ease of use. It's very easy to just say, oh, we've got an easy-to-use system. Traditional robot companies do it, and then you watch videos, and it's very complicated. Very few companies actually show you what it takes to set up a part, go through the process of teaching it, tweaking it, and we're going to do that today.
Yeah, and I love the quote here that was shared by Royden, because he talks about, they got it because of improved cycle times, but then they realized it also helped improve the weld quality and the consistency of the production and how many parts they were making each day. And I thought that was really powerful. So, you may justify it with one ROI, but it's going to bring many other points of value beyond just a productivity bonus. Yeah,
for sure. PMI up in Wisconsin, they were actually, I think, maybe the first user of our Cobot technology or Cobot welding technology back in early 2019. So sometimes people ask, as new to Cobot welding, how long have you been doing this, or how long have these been out there? And we're one of the first to be doing this. PMI has been out there since early 2019. Running welding systems. They have traditional welding robots. They have other UR applications elsewhere. But it's so easy and powerful that they continue to bid on more work with more Cobot welding solutions. Next one.
Awesome. Yep.
Skivington is a great case study with our partners at ESAB. It's a Canadian company, and they were looking into Cobot welding. They struggled. The story for all of these is the same. We cannot find people to weld the parts we need to weld. We cannot find and keep skilled welders. That's where it starts. That's the entry point. And they get all these other benefits. So Skivington was literally tens of thousands of parts behind on a job that they were doing for one of their customers. And when they got introduced to the Cobot, the ESAB Cobot, it's the version of our system that you see behind me, they literally took it that day. They asked they wanted that demo system. The next day it showed up on their site. It wasn't the one that they were buying, but they're like, I need this. And over the course of that next 30 days, they produced all the parts that they needed. They got caught up on a job that they were prepared to tell their customer they were behind. And they're just emphatically, happy and love it, how productive, how easy it was for them to be productive so quickly.
I think that's a great story. And the weld quality is going to be important to folks like this because they're making retail displays and store fixtures, right? And so these are things that are going out in the commercial space where people in society are seeing it. And so look's going to matter on those kinds of products. And so I'm sure that got them excited too, that the quality was going to be there that they were looking for.
For sure. So Spectrum Metalcraft in Salina, Kansas, they have two systems actually at two sister companies in the same town. Another success story, right? They have traditional robots. They wanted something that was easy to use. Production was important. They couldn't find welders. To your point, Will, quality and consistency matters. And they're just, one of those many customers that are just thrilled with how quickly they can get up to speed. Here you see Thomas asking a question in support. And so we'll show that today. This is not just making a robot go from point A to point B, but it's the entire experience, which includes, what do you do when you have questions? How easy is it to get in touch with somebody? How easy is it to get answers? And so all those things sort of break down the barriers and de-risk an investment in Cobot welding.
Love it. And I love the quote here about, being able to increase profits by just cutting out overtime, and actually cutting overtime makes the quality of life of the welder better. Right. And Absolutely. So this is a really awesome story. It's a great one. Good. I don't know how to say this. 1-3 Designs, I think.
Yep. So this is a system that was developed in conjunction with a partner of ours, Kinetic. Kinetic's a great partner that has tons of experience in welding, but also into fixturing and fixture designs. And they have an awesome RT1 kind of manipulator that can spin larger parts or have like an A side, B side. And it can be incorporated into the Cobot today. And so they're a great partner that has deployed several of these out and around. And sometimes people kind of can't envision, well, how do I put my part on this table? And they've done some amazing work with customers that have large parts that are complex, that need to be repositioned and take advantage of our easy to use software to handle that.
Yeah, there's some great videos online. If you look for that RT1 from Kinetic Technologies, there's some great big parts being made on tables. So yeah, definitely Google that. And then last but certainly not least.
Yeah, Advanta, great longtime customer, has two facilities, one in South Carolina, one in Michigan. They produce parts that go into the automotive industry, not in-car parts, but kind of supplying and material handling up to the line. They do work for Tesla and other companies like that. And they started out small. I think they started with 2 systems. They're now have more than 20 systems across their 2 facilities. One of the powerful things that we'll touch on a little bit when I go through this demo is the nature of the software allows them to share parts between facilities, between robots, using that same tablet interface. And so no USB sticks to back stuff up, and how do I get this file to that robot over there? And so this has been a great story where automation has helped them bid on and win more work and grow their business.
Yeah, and I love the service. I mean, you're going to talk about service, but you can see here, they only had to use it twice, and they were back and running within 30 minutes. Just through the app, they were able to interface with the Hirebotics crew. I thought that was a really great story because production time is really valuable time, right? So great story too. So Rob, I'm going to turn off my camera here, and I'm gonna highlight your video. So if people want to blow your video up, you're going to run a live demo of collaborative welding for us, right?
I am. Yep. Thanks, Will. So
Awesome.
One of the things I want to say, and Will did his presentation sort of leading up to this, but this shortage of skilled welders has been going on for a long time. And I remember there's a 1998 American Welding Society study that emphasized and highlighted one of the concerns that manufacturers had in the 90s was the shortage of skilled welders, the aging workforce, all the same themes. And I point this out only because robots have been around for a long time. Cobots are newer to the scene, but these problems haven't been solved, right? So the traditional method of solving these problems for manufacturers hasn't solved the problem. The problem exists still today, and it's only gotten worse. So what you're going to see here, I'm going to share the screen so you can watch what I'm doing. You're going to see me teach some parts. We've got a little sample over here where we're going to do a live demo. Most of the time, we don't even weld in these demos because people understand that, ESAB or Miller, or whatever power source they get with our system, they know how to join metal. So this is a story really about how easy is the software to use and can I empower my people with it. It's one thing to watch a video on YouTube of a robot doing something, but the real story is how did you make it do that? How did the software enable someone to make it do that? So we're going to walk through that now.
Okay.
Hopefully you can see my video. I'm going to share a tablet that I have. So just as a quick background, our software, we develop it in-house. It runs on iOS devices. I've got an iPad mini here, Android, web. You bring your own technology, whatever your welders are comfortable with. This is the first layer breaking down the barriers. You hand a teach pendant to a welder, and now, sometimes their eyes can glaze back. They might have to go off on some training. Even as easy as robots have gotten to use and universal robots have gotten to use, we break down another barrier by giving them a tablet that they're already comfortable with. Anybody can use an iPad. So we're using an iPad here. A few things I'll point out as I run through this demo. Across the bottom, we can see a few different tabs. I've got a home tab. Customers can see these are on some demo robots, but they can create their own charts and chart cycle time and consumables used and all sorts of things like that, whatever's important to them. We're looking at this on an iPad, but some customers put a big screen up in their shop. Maybe the owner wants to be able to monitor things from home. They got the flexibility to do that. We're going to spend our time on the robot tab where we have several different robots here. We're using the ESAB demo, so I'm going into that screen right now to see all the different parts that we taught. We're going to teach a new part here. Now, a few things I'll point out, especially if you're new to collaborative robots. This is safe to be around. I can walk up to it. I can move the robot around by pressing a button on the back side of what we call the puck. There's two buttons here. The top one, when I press it, allows me to hand guide the robot. So welders could do the same thing I'm doing and move the robot into position. And the bottom button is going to interact with the software. All motion is always initiated from this button box that we call it, or an operator box that's wired into the robot with an e-stop, a play button, arc on off switch. So we're just going to go through and teach a part that I've got here set up like this. It's got a few different pieces of geometry to it, and we'll go through and teach it. And so I'm going to hit the blue circle button in the bottom right. I'm going to give this part a name. This is typically the hardest part of the demo. What do I call this part? But a customer would give it a part number or drawing number, something that they would want to recall it later. We'll just call it webinar. I'm using the 22-degree short gooseneck. So I set that up. Now I can, if a customer has saved weld procedures into a library, you can easily pick some settings from a library. I'll just say use these settings. Those are my defaults. And now we're ready to teach welds. Now the data shows that most people are teaching linear welds and air moves. So we prompt the user to start with linear welds. You can always change it to different type of motion. But we're now going to hit the button and we're going to bring the robot into position. And we're going to click that blue button to teach our first point. So I just taught my first linear weld just by clicking that blue button. I'm going to move it to the next point, click the blue button to teach my next position. I'm going to move it to the bottom here, teach my next position. And then I'm going to, the last point here. Now I haven't taught any air moves. I haven't taught approach points. The software figures all that out on its own. We can always add that later if we need to, but I'm going to hit save. Now, similar to Apple Music and Spotify, we have a concept called a playlist. And so what's on the playlist is what the robot's going to run when we press play. You can have one part on your playlist like I just taught here, and I'm going to create a playlist with this part, but you can teach parts independently, throw them onto a playlist just like songs in a music app, and you can run different parts sequentially to run A side, B side, or 3 different parts if you want to. So we've taught this to run. We told the robot we want to run it. The arc is off. We're not trying to weld this part here. I'm going to press play, and we'll see cycle through this. Now the speed at which it's traveling, the torch angles that I gave it are all what I kind of hand guided it to. The travel speed is in those settings that I had when I chose that library setting. And it's going through the different points right now, which we can follow along in the software. Now, as it's going through that, I'll point out a few different things just in the interest of time. On any of these points, we could tap on it and we can see the weld procedure for those points. We're in a pulse process. We've got a 22 inch per minute travel speed. Trim is set to 0, wire feed speed 400. For any taught point, we can go through and tweak those settings. Now it departed the weld and it went to its default home position. Now I can just as easily make this more sophisticated by tapping the magic wand, hitting the plus to teach some more points at the end. Maybe I need to have an air move here because I need to weld the backside of the part next. So I can switch to air move just by pressing and holding in the blue button. It lets me toggle the air move, and we just taught an air move. I can toggle back, and I can switch back and teach points on the backside. And we'll just do like that for now, and we'll hit save. So very easily, I can add to my part. I can teach a much more complicated part. I can press and hold one of the icons because I want to skip part of the weld and just have it go from there. Go to the air move and do the backside. Notice again, it'll depart the weld and it'll go to its home position. So very easy to interact with this. You know, we're running this on an iPad and it's going to go home. So now I'll answer the question that people always ask. I got to see it weld. I got to see it spark. So we're going to teach a little part over here. We've got just a little lap joint. So I'm going to go back and teach a new part. We'll see how I do here. I'll say webinar 2. Hit next. Choose those same settings. So now I'm going to come in here. I will teach my first point. I'll come over, teach my second point. We can do a dry run if we want to see it again. We can even do something what we call step mode. So if we want to go step by step, stops at the points. I can look at where the torch is. If I wanted to make any changes, I can move the robot around from this point. I could recapture that point if I needed to make any adjustment. But if I'm happy with it, I could play it through step by step. But we want to see it weld because people want to see, can the welding companies join material? They can, I promise. This, it'll go home. So now I'm going to move out of the way, get into a safe area behind a screen. I've got the operator box over here. I'm going to turn the key switch on. And we're going to hit the play button to see it weld. So pretty easy to run the system. A few other things I'll point out real quick, and then we'll kind of get to some Q&A. I mentioned this earlier. Customers sometimes have questions. They want to reach out. Different than any other system out there, they can drag it open to the side. They can hit support. Within support, can we see this? Can't tell. I think we can see this. Might have taken up.
I can see it. Yep. I can see it.
In there, we can search knowledge articles. Oops. We can reach out and ask questions by sending a message in. And we're really proud of this, but if you have any questions, you can reach out. In under 2 minutes, you're going to hear from us. And so very fast response time when you have questions and want to reach out to a human and get some answers. So with that, Will, we can open it up to questions.
Yeah, and I just have a little bit more just to wrap up. Thanks for that demo, Rob. That was really amazing. I think what's incredible is how quickly you taught 2 parts with 3 different paths in like 14 minutes, I think, more or less, is what you did. And you were actually live welding a part there. And I think the power of this, right, to be able to go through and set that up. And if you have consistent, if you have standard kind of setups that you normally have and certain speeds and gas mixtures and those things, you can have all those preloaded there, so it's even faster, right? That's what you're kind of showing at the beginning. Right. Yeah, that's awesome. Okay, so I want to switch over quickly to just a few slides to wrap it up, and then we'll dive into the questions. There's some nice questions in here. But the first thing I just want to point out is the welder is at the center of all of this, right? They know what speed it needs to go, and they know what's the setup of the power source that we need. And so collaborative welding tools are not replacing the welder. It really needs the welder, and it needs someone with the welding knowledge to make it happen. It needs their skills and their understanding and all those things, but it's really amplifying what they're doing, and it's making them a more contributing member to the organization. I love this picture here. I forget which company this is from, Rob, but this is one person operating 2 robots at the same time.
That's right. Yeah, that's Advanta. So that's 2 of their systems, one of their welders, right? No experience with automation, but he can load and go on multiple systems.
That is awesome, like really powerful. And I think that's just a really powerful part of this is it's really enabling that welder to run 2 arcs at the same time. How many welders can hold 2 torches at the same time and do welds, right? Like and what are the quality of those welds that they do it? And then, when we talk to experienced welders, when we interview them and we get it, one of the biggest things I hear is this extends their career. People who are so tired and exhausted, they don't think they can do it anymore. And you still need welders, but you don't want them to retire. This is an investment to keep them around for 3, 5, 10 more years because they don't have to do the physical parts of the job. It can help extend their careers, push out their retirements a little bit, and help you keep your productivity levels without losing that welder because they can't do the physical parts of the job anymore. And experienced welders tell us things like it gives them more energy and they have better work-life balance. It produces at their quality expectations and what they expect to be done. And it's their work when they're teaching the robot to do this. And it allows them to focus on more creative and more challenging work and not just do 200 pieces of a 6-inch straight line weld. And then, when we talk to early career welders, people new to welding, what this does for them is, it stops all the mindless welds, that 200 pieces in 2,000 pieces even in a 6-inch straight line. Young welders get the less interesting jobs usually, right? So it gets rid of that kind of mindless work that they're there. And they aren't doing as much over welding, so they don't have to do as much grinding. And so they have, it also empowers them to feel like they're contributing more to the organization and to be responsible for more in the organization, right? I run robots and I run welding robots and I teach welding robots. It allows them to have that feel of more responsibility that young people are always looking for in organizations. And then when we talk to business leaders, there's lots of interesting things they tell us, things like reducing the impact of the skill shortage and, better planning of the production levels, being more consistent day to day and allowing them to know how much arc time are they going to have each day, reduces the operator fatigue and potential chances for injury, and it reduces waste, which is a big deal, and eliminates just post-weld grinding. No one wants to grind anything, and so that's really something that people don't want to do, and something that really, if there's an opportunity to reduce that or eliminate that, that's there. And business leaders go on and tell us all kinds of things like it removes bottlenecks. A lot of times the weld shop's the bottleneck, or it fills gaps where they have traditional robots, they have manual welding, but sometimes it doesn't make sense to set up on the traditional robot, but they wish they had something that was better than having a manual welder weld 2,000 of the same parts. It fits that really nice gap. And we hear over and over again, this implements really fast with a strong return on investment calculation at an affordable price for shops of all sizes, and hear that over and over again as we interview people. And ultimately, it enables you to be productive even when you have open welder positions, and all of us have open welder positions right now, and it really then helps your company to boost your productivity and ultimately your profitability. So just a refresher that collaborative welding is this tool augmenting your welders that expands the manual welder productivity, it raises the arc time, it drives production consistency and the predictability of the output of the weld shop, as well as the quality of the welds, and it's really increasing the welder engagement and your retention of welders, and even attracting welders to your shop to make that job more interesting and that they want to stay in working with you. And so Hirebotics, Rob's with Hirebotics, really Hirebotics is trying to make welding cobots easy, that you don't need experts, you don't need robotics people to do it. They are absolutely the industry first welding cobot that has this, intuitive smartphone tablet app that you saw today. Really cool. And they make a commitment on their site, industrial grade welding cobot systems shipped within 2 weeks and running parts and hours. And you heard that over and over again in the stories that we were talking about. And the 2 minutes of response time through the app is just, that's incredible, Rob. You're able to help people get running quickly. That's really powerful.
Yeah, it's one of those things that we tell people, like you just mentioned, Austin, and the first time they have a question, it could be, where does this go? Or how do I set this up? Or, how do I do radial welds? They just get blown away that they get answers in minutes, blown away, not hours, not tomorrow, not 30 minutes, just answers right there, right away. So sorry to jump in there.
Yeah, awesome. And I mean, Rob, if you want, you watch this and you think someone in your organization needs to see it, scan that QR code there, or hit the bit.ly, or go to the Hirebotics website. They have a nice link to schedule a demo and to be able to see it for yourself with your questions and your specific conversation with Hirebotics. They've got a really nice, then they also have a really nice blog that's available about getting started with Cobot Welding, where they answer a lot of really nice questions in the blog in a very easy to read and follow format. So make sure you check out those two things. And Universal Robots, that's really, I got to talk about it. UR is really the market leader for collaborative welding. We are on our 5th generation of Cobot, and we are doing actively welding-centric developments for the Cobot, which is really unique in the Cobot space. There are many Cobots out there, but UR has had a lot of experience in this. Rob mentioned, collaborative welding is not new. We have more than 5+ years experience. You heard 2018 from Rob, so it's really a long time. And this is more than any other robot company. Most other Cobots have entered this space only in the last year. And so we have a lot of experience. That means we have 50+ local partners and integrators available around the world. Hirebotics is expanding their reach and availability, and even through ESOB network. And then there's hundreds of years of welding experience in our community, as well as many partners offering components to go nearby. This is like maybe another Cobot for loading the cell with a gripper or something. And then we have thousands of successfully deployed Cobot welders around the world in virtually every country, and in many, many different industries and applications, from semiconductor to the automotive industry to mobile equipment and even food and food equipment. So there's a lot of really interesting places where our Cobot has ended up. And UR is an organization, we want to create this world where people work with robots, not like robots. We want to get rid of those physically challenging tasks and focus people on using their brains, not their brawns, right? That's really the trick. And so if you're interested in collaborative welding ROI calculator, we have a tool that we can share with you to calculate a return on investment if you're looking for that. But remember, it's not always about the productivity return on investment. It's also about that quality level and the predictability of the output and how much arc time you get each day. And it's also about that return on investment on retaining welders, and what are you doing to expand the engagement with your welders and retain your welders better. But I have that tool, and you can send it to me. So we're going to move on to the question and answer part of it. So Robert, I am going to turn it back over to you and let you lead the end of the webinar here.
Thanks, Will, and thanks, Rob. That's been a great presentation. A few of our listeners, viewers have already submitted their questions, and we're going to jump to those right away. But as a reminder, I want to ask everyone, please take a moment to complete the feedback form that will appear on your screen at the end of the webinar. Questions, let's begin. What do I do when something goes wrong with this solution? Am I on my own?
So good question. The answer is no. We get questions all the time through support. Sometimes people are literally just sending us messages to show off something that they've done. You can request features and enhancements, but we empower the operator where they're at, standing next to the cobot, the same device that they're using to teach parts and run the system. If they have any questions at all whatsoever, they reach out an app, they hear back in minutes.
Okay. What kind of welding project is best to start out with?
It's going to vary from customer to customer. We see on average, people run about 40 to 50 different part numbers on each cobot that they have. So unlike, some other automation applications where they're trying to justify on a single part number, it's a little different here. So we typically recommend starting with smaller parts where there's not necessarily even high volume, but I run 100 this week, I run 50 of those next week, some sort of mix like that. And those are really easy to set up and get going. And then as people get these, they get into more complicated and advanced teaching of parts. But we usually say start with one or two ones that are straightforward that you run on a regular basis, and you'll see how quickly you can get up and running on those. And it's kind of land and expand from there.
For large parts, and the example offered is construction equipment mainframe structures, what strategy should be taken to implement cobot welding?
Yeah, so we're happy to get on a virtual demo with you and kind of talk about your specific parts. But I'll say we have customers. Athena was one where they do large frames, and large is all relative, right? Some people large is 10 feet, and some people large is 20 feet or 50 feet. But Athena is a great example where they have 4 different cobots, and when they run this larger frame that goes into the semiconductor industry, they can't reach it with one system. And so they have 2 cobots that sort of work together that they taught. And so they've got a table set up that allows them to put larger parts between 2 cobots and run them. The other thing I'd point out, and FabTech is right around the corner, so if you're not coming, you should come. But UR has been teasing us all, right, with the UR20, and we're finally ready. Not just us, but UR is going to have it. We're going to have it. Come to FabTech. The UR20. This is the UR10. It's got a 1,300 millimeter reach. We generally tell people, just for easy discussion, you got about a 48-inch usable reach because you want to have a good torch angle. But the UR20, it's pushing 69 inches of usable reach in all directions. And so we're going to have it at FabTech. Come by and visit to do even larger parts or have 2 of those working together.
This questioner starts with a quotation from one of the case studies. It's the future of small welds. What about 7th axis rail systems or leapfrogging with these systems?
Yeah, I mean, you can get pretty advanced if you want to. There's partners that have 7th axis systems. Kinetic is one that can help design something like that. We don't typically recommend people start there because what we don't want to see and you don't want to see is people have lots of ideas when it comes to automation. What if I did this with a robot? What if I did that? You can absolutely do that with universal robots in our system. But the best path for success is start with the easy stuff and expand from there. You can absolutely put on a 7th axis that you can have positioners connected to it. You can do all sorts of wild stuff, but it's not just for small welds. The small welds are the obvious ones.
What is the range on the cobot arms?
Yeah, so this is about a 1,300 millimeter reach, or it is a 1,300 millimeter reach. Like I said, we generally guide people to about 48 inches of usable reach because torch angle is important. But don't be confused by the table size here. We can easily teach things that go off the table. We can have parts that come off in this direction. And so that reach of the robot, in this case, 48 inches, is in all directions. Like your arm having a 48-inch reach. And then the UR20 is going to be about 69 inches of usable reach.
Mm-hmm. Yeah, it's definitely a radius, not a circumference, right? Or diameter.
Yeah.
Can you program curve welding, and how?
Absolutely. So in that teach panel that I said, we start with linear weld because that's the data shows that's the most common. All we have to do is drop it down and switch to radial, as we call it, for at least 3 points, and you're just teaching them around a circle or a curve. You could do more than 3, but you need at least 3 points. And some people ask, just because other brand cobots struggle with small parts, but I mean, we could do this, the head of this shoulder bolt if we wanted to, small circles, no problem. But very easy. You just switch to radial and teach your points.
Realistically, how quickly can I get from order to production? What's an example of worst case and best case?
So let's say you said, this is fantastic, I want one of these. You could place an order, depending on inventory level. We usually say about 1 week till it ships, but sometimes it's 1 day. We build a standard product. When this lands on your floor, it's going to take about an hour and a half to set it up. Everything from the table down is wired, ready to go on a pallet. The arm is in a safe box, collapse down, drop in 4 bolts, put the dress back on, put the puck on. 45 minutes, you're up and running and teaching your first parts. And you could be running production parts that afternoon, no question.
Does the equipment offer crash prevention safety features?
Yeah, so this is, we talk about cobots and sometimes, we take this for granted, right? The cobot will stop if it collides, right? So this is a huge benefit for welding. I'm going to turn the arc off. If we hit play and the robot starts moving, I put my hand in the way and it stops. Mm-hmm. So that's useful. People want to understand the benefit of that for human safety, but it's equally as important for tooling and fixturing, because we've got a piece of tooling here. If the torch runs into that, in traditional robot world, you're bending the torch, you got to have a torch straightener, you've got to do some calibration work. It's a real pain in the collaborative space, especially with robotic torches that we use that are keyed and meant for heavy duty applications. It's going to stop, you're not bending anything. And so it's got force sensing in the arm. We rely on that to keep your people safe, but also to keep that torch safe so that you're not bending things if there is a collision.
Great point, Rob.
Good. Can you vary the temperature during the weld?
So good question. We did, this part that we taught, pretty basic, but had some interesting geometry. And we just taught parts where there was geometry changes, but we could just as easily teach multiple points along a path. And at any given point, we can change weld settings. So if we want to change heat, at a certain point, we just drop in a new point and, we can change settings on a per point basis if we want to. So the answer to that is yes, through teaching points and controlling the weld parameters between those points. They could be points that are really close together if you need to.
Okay, I think you already addressed this, or maybe this questioner wants a little bit more clarity. Is it possible to integrate a linear rail into the system for larger components?
You can. It's, you start to get into more sophisticated systems. The time to get up and running is longer. The work to teach those parts is more complicated. Short answer is absolutely. We're all engineers probably asking those types of questions. And so we like to think of like the most complicated problems to solve. You can absolutely do that. But generally, the best place to start is the easy stuff, the boring stuff, right? Get those done and get out of the way. But if you wanted to use a 7th axis or a positioner, absolutely.
This questioner is asking for an opinion. How do you think this robotizing in welders will help supervisors and or iron workers who dealing with the capacity issues and the availability of supervisors, I guess?
Well, so as I mentioned kind of earlier, when Will and I were chatting, on this webinar, is that this problem of the shortage of welders, it's not a new phenomenon, right? And it's been happening for decades and only getting worse. And so I like to emphasize that because we approach this differently, right? We're literally on an iPad. Robots have been around forever. Cobots are newer to the scene, right? But you really got to empower that welder to give them a force multiplier. And collaborative welding does that. Our system does that to even a greater degree. And so as you can make people more productive, lots of things get better for the worker, right? They're, as Will said, they're not in the fumes. If you can have one person operating 2 cobots and maybe they're doing something by hand, right, while the cobots are running, that person's more productive. When people are more productive, wages increase, right? All things that benefit the worker, the work environment, the company to be more productive.
Yeah, and I would add on top of that, Rob, I mean, it makes the job of the supervisor easier, right? To be able to, they don't have to worry so much about the individual quality. They can really worry about the person themselves rather than the output of the product. And that's, you know, you really, when your manager cares about you, then you care about your work. And so it creates this positivity cycle inside a workspace because there's less like nitpicking over the quality of a weld because the weld quality is more consistent out of the cobot. So there's a lot of pieces here. And, you know, cobots are used for other parts of this. You see cobots, not the Hirebotics solution, but there's finishing cobots and there's cobots used to do cutting and some of the other processes around welding to add value to other workers that aren't just the welders in the metal, in the fabrication shop.
Okay, I'm just going to read this question because I'm not sure that I can rephrase it as clearly as I think it ought to be. How easily can you program different loose welds and walk away without the cobot hitting all parts of the construction? That is to say, of the jig of the setup.
Yeah, so I'll make some assumptions. What I think the question is, we did a pretty basic part that we taught, and then we did a pretty basic weld over here that we taught. And what I was emphasizing maybe too much was, if you have real basic welds, you don't even need to put in air moves, but you know, to approach or a home position or anything like that, right? The software understands what it's trying to do. But that was a really basic part. We can teach parts, we can add air moves, we can add lots of air moves, right, to kind of clear things and get to another point where it's got a weld. You know, we have the ability to pattern and shift and add air moves in between those. And so if we taught, you know, a part in this area of the table and we wanted to have 3 more of them or 2 more over there, we could teach it once. And through the software, basically copy and paste it by literally just moving the robot and clicking the blue button to pattern them. But through the combination of welding moves, which is what we use to teach this part and do that dry run, and then this part over here and do the weld, and air moves, right? You can clear anything you need to go and have that robot swing around and kind of get into tight spaces, avoid obstacles and objects, avoid your fixturing.
And one thing is the UR Cobot has a very repeatable path, right, Rob? So it's not like you teach it, it does the weld twice, and then it does it on a different path the next time. Like, it's a very repeatable path. And so if you've taught it and it's not collided with any of the constructions or it hasn't collided with any of the fixtures, you can rely on that it's going to move the same way each time.
Yeah, we like to say when we're talking about repeatability, like you mentioned, Will, and this is nothing against the welder. It is more repeatable than the human welder, right? The path accuracy is more repeatable than the human, right? And this is why people get that consistency.
Is the robot or cobot hardwired or Wi-Fi connected or both?
Great question. So the controller has an Ethernet port in it. We have software that runs on the robot controller. And so UR is a great partner that has an open platform, so we can have our software run on it. But it is a hardline Ethernet connection. Now, there are customers that have, don't have a drop near where they want to have their cobot welder. And so they sometimes are running a hard line, which we always recommend, but they can run Wi-Fi and have a little Wi-Fi bridge. Some of them, I think General Electric has one, and they're on cellular. And so it just needs it needs to be on the internet, an internet connection, right, through that Ethernet port. But how you get it there is up to you.
Does the software, the program software, integrate with other third-party software platforms, such as an ERP system?
So really good question. So Beacon, because that data, as we were running those parts, is publishing data to your account in our software, we have the ability to do webhook callouts. And webhooks, if you're asking this question, you might be familiar, but it's a sort of generic mechanism to send data from one system to another. And so if you've got ideas, right, you have something like this and you have ideas on integrating it with other systems, we don't do that integration for you, but the tools are there through our software and external webhook callouts to send data to another system.
So you could post how many parts were made in that shift to a board or something somewhere else in the plant, maybe, or they could suck the data out and they could post it somewhere.
Yeah, and by part number, right? So we put in the part number, right? So the data that goes out has the part number. It's got, I made one of them, I made two of them. If you cared about tracking your consumables, right? Like all that information could be pushed out to an external system through Beacon.
That's really slick.
I think this will probably be the last question. Can you run a mirror path if the geometry permits, or do you need to teach the new points for the opposite side of a symmetrical part?
So great question, right? And this is going to, I think, reveal how we think about product development. So today you can shift and pattern, which isn't what you're asking for, right? You're asking to mirror, right? You got a left and a right. So today we don't have that support. You would have to reteach those parts, but we've gotten that feedback from other customers, right? It's on our backlog of features. And when we do add that feature and capability, your system suddenly gets better through automatic software updates, and then you have it.
Really cool.
Very good. Again, this has been an excellent presentation. I want to thank our speakers, Will Healy III and Rob Goldiez, and our sponsor, Universal Robots. On behalf of New Equipment Digest and American Machinist, have a great remainder of your day.